Hello, everyone. My name is Julian Roedig. I'm here today with Patrick Lanners. We are solution architects from the BMW Group, and we want to talk today about the transition from our Configurator platform to the AWS cloud. Can you imagine how many combinations you can configure if you configure a BMW? Take this example. If you will configure this BMW 3 Series, for example, in Germany, you can choose between 15 engines, 15 colors, 20 wheels, 30 upholsteries, 15 interior trims, and almost 100 more optional equipments. From a math perspective, you have millions of possibilities to configure your dream car. But not all combinations are constructible. At the end, the car has to be constructible. For example, it makes no sense to configure 2 navigation systems into one vehicle. This BMW 3 Series is just one example out of many. Our Configurator platform deals with the vehicle data of all brands BMW, Mini, and BMW Motorrad. The vehicles are sold in 140 countries, so our platform has also to take care about the special local requirements. It's helpful if not every system has to start from scratch, so the data and functions like a constructability check is really complex. Therefore, we built this Configurator platform, which other systems can use. On the slide, you see a selection of front ends which use our Configurator platform. The first one is a configurator used for dealers. It's running on an iPad. The other configurators are web-based configurators. They are embedded into the websites. Currently, there are 26 more applications are using our platform, and it's increasing from week to week. Some of them are internal applications, for example, to create an offer. Some of them use our data for AI or prediction purposes. Internally, we call our project UCP, a Unified Configurator Platform. So based on our API, other applications can deliver a front end, for example. We have 300 RESTful endpoints currently, and some 100 million API calls. On the right side, you see an illustration, a rough architecture of our platform. So client applications can use, for example, data services to get, for example, vehicle data, or the accessories or image data, or data for marketing descriptions. They also can use functions like price calculation, a tax calculation, or a constructability check. The data is initially not maintained within our application. We retrieve this data from the BMW landscape. To not depend on the BMW landscape, we import the data into our platform. Some data is just imported, it's really easy, and some data is transformed or generated. We had 3 big topics on our way to AWS. So first, I want to talk about the old platform. A monolithic system has advantages and disadvantages. In the second part, I want to talk about how we cut our microservices and which practices we followed. In the third part, Patrick will tell you all details about the transition from on-premise to AWS. So let's start quick with the monolithic application. Today, everyone is talking about microservices. So is it good to start straightforward with the development microservice? For us, we can say no. At the beginning, here in number 1, we had no microservice. The platform was a single system. Of course, we had software components, but these components were not distributed. The development was really fast, and we could deploy the first MVP fast to the production. We got more and more additional requirements to our system, and we could implement all these features. This was good because we could satisfy the client applications, and our platform could deliver a real value. But you see, at number 2, the productivity was decreasing a little bit. I wanted to develop a small feature. I went to my developers and I said, please, can you implement the small feature? And the developer said, oh, the feature is not the problem, but before we have to refactor this part, and that part of the system. Ooh, what was happened? We were fallen into the hole at number 3. We had, at first, the speed was really fast, but now we had to think about new solutions. And from the point 3 to the point 4, we decided to implement or divide the system into microservices. This was an investment, but it was necessary to get the pace again. The second part is how we have divided the system into microservices. We were really lucky, so we had many experience out of our single system. It was for us really important that we know much about our data. So if that is the case, you know much about your data and functions, you already have an idea how to divide the system into services. Without going deeper into the philosophy of microservices, the key for us was a loose coupling and high cohesion. For example, we have a microservice which only do the tax calculation or the price calculation, or a microservice which only deals with the marketing data. Yeah? At this level, we started to design our functional landscape. You see on the bottom a small diagram. So there we focused on 3 questions. Okay, what are our microservices and what are the dependencies between these microservices? The second one is, what are the dependencies to our BMW landscape? Because also the data which comes from BMW is important and can move the microservices around. So last but not least, you also have to think about what is a good microservice card also for your customers. So in the second part, we went one level deeper into the domain-driven design. We now had a rough understanding of our microservices, but this was not enough. So in the second part, we started to define business objects of each microservice. And a business object is a logical representation of your data, which lives in the microservice. This step was also really important for us. If you have a business object, and the business object is available in one or more microservices, you have to think about it. Is this object really necessary in 2 or more microservices? Maybe I can move the object to another microservice to reduce dependency. If the object is living in 2 microservices, you really have to think about consistency. So we learned a lot about the second step, and we adjusted the microservice card from step 1. So the step 1 and 2 for us was kind of an iterative process. Now we can go to the step 3. It's the API first. If you imagine you develop a fancy web interface, would you start to develop the web interface without wireframes? I normally would expect that you already have a full visual design. Yeah? You don't start to just develop a web interface. Yeah? It's the same with the API. At the end, each business object from step 2 must be represented in 1 or more RESTful API resources. We have done this on best practices and designed a RESTful API, and all business objects are you find in this API. The attributes of the business objects became part of the JSON request response payload. We all have done this with a RESTful RP modeling language. Yeah, it's a RAML. In the meanwhile, Swagger would probably be the better choice for us. We have also generated out of this description, of course, an HTML web page. So you find on GitHub many tools which transform this Swagger or Ramble file to a web page. This is really important that all stakeholders, all customers, so the whole team has access to this documentation. And for example, if you're sitting in a meeting, you just open the API specification and you can talk about it. So it's a really good explicit communication medium. Like we have done it with the API first, we also wanted to define the tests before we start with the implementation. So as important, it is important to have a short test cycle. Yeah? We wanted to take advantage of the cloud and also continuous delivery, so we had to make sure that our quality cycle is really in place. Yeah? Also, it's a good side effect, a good test optimization gives everyone in the team and all stakeholders a lot of trust. So if you, for example, deploy daily or weekly. Yeah? In step 5, development, for us it was easy. We had just to take our API specification, our test definitions, and maybe some more acceptance criteria like non-functional requirements to a user story, and we had to push this user story into the product backlog, and it was developed. Almost the whole effort to define the user stories was already done within the API specification or the test specification. So this is the reason why in our project the product owner are defining the API, the tests, and of course also the user stories. I don't want to go deeper into the point 6. I just want to give you one thing on the way. The API is not perfect, never. So you have many different customers and different systems with different use cases, so you never will have the perfect API. But you have to analyze your customers. So how are they using your API? This is really a good source for further optimizations. Here are our top 3 learnings about the transition from a monolithic system to microservices. A monolithic system is not bad at all. It just gets dirty if the system becomes too complex or too big. So don't start straight with a microservice if you don't know your context. Yeah? You are slower. Yeah? Instead, start creating microservices when the single system becomes too complex. And the second, everyone is talking about user experience. As the developers, mainly the users of the API, we have to think about developer experience. So it's a good start if you use an API first and domain-driven design for it. Last but not least, as everyone is doing microservice, so it's modern, but please don't build a distributed monolithic system. Yeah? It's important to reduce all dependencies on runtime level and also dependencies during the development. In our case, our microservices, of course, have an own Git repository and also an own continuous integration pipeline, and every microservice has its own releases. Now, as our software is ready for the cloud, I think we can go further. As mentioned before, our platform is used in 140 countries, and it's possible to cache some of the services, for example, in a CDN like AWS CloudFront, but not all services. So due to this reason, it was necessary for us to distribute the compute engine and the compute power worldwide to bring our configurator software closer to the clients. So Patrick will tell you now all details about the lift, think, and shift strategy from on-premise to AWS.
OK, thank you, Julian. So let us talk about the transition from on-premise to AWS. We have been a team of 5 internal employees of BMW Group, and our goal was to bring all our microservices from on-premise with 100% in-house effort to AWS Cloud. We had the approach that we had used also AWS Professional Services as a coach on our side, so that we have a bit of acceleration at the beginning. We started with a 2-day onboarding with them, and we came up with an initial plan how we could do the transition. Followed that, we had a 4 intensive week where we set basically all our accounts, and we had the transition of the first microservice to AWS. Let us have a look at a high-level perspective of how we did the transition. On the left side, you can see all the artifacts that we had on-premise. Our goal was to reuse as many options, specifications, or artifacts that we have. You see that we had the API specification that Julian told before that is written in RAML, and we had also the authentication informations for the REST endpoints, so basically what user can access what REST endpoints. All these information is packed. We created a script to transform it into the API gateway. Here it was necessary to transform the RAML specification into Swagger so that we can import it into the API gateway. Our microservices are all written in Java. So we basically have a Glassfish 4 application server, and here we choose the way to Dockerize all our business logic and to deploy to Elastic Beanstalk, which is a platform as a service, as you might know. What is also important is for us, we want to guarantee that our microservices have a high degree of autonomy. So for us, it is necessary to import all the data, as also Julian said before, from the on-premise network from BMW. Before we went to AWS, we had a database on Oracle, and we did the import jobs throughout PL/SQL scripts, and this we have rewritten into Java so that we can reuse our import job in the same way as we do with our microservices. For cost efficiency purposes, we went from Oracle to Postgres also. And in the next slides, I will go to some details, for example, how we did the authentication now with the artifacts that we had from on-premise in AWS, and how we are doing the import jobs. So let us have a look at our architecture. I will now go step by step to the complete architecture so that you get an idea how our architecture looks like. We are using Route 53 for our public domain name and CloudFront for one point of our global distribution strategy, basically for caching purposes and also to have a fast entry point into the backbone of AWS near to our customers. Within the API gateway, each of our microservices gets its own API. And for authentication purposes, we are using API keys. And as you can might see underneath of the API gateway, you see a Lambda function. This Lambda function has basically the job to do the authentication. It retrieves the information for each API key throughout the DynamoDB. There are all the informations that we had from on-premise. So basically all the REST resources with the authentication informations. Let us then move a step forward. Our basic setup is consistent of a VPC, and we decided to structure it on a subnet level into the 3 subnets. Regarding the purpose of each component that we have. So within one subnet, all the load balancers are located, in another, all the applications and our databases. From a security perspective, we wanted to achieve that we have only one single entry point into the VPC, and that none of the, for example, load balancers can be accessed from the internet directly. Here we are using the VPC link from the feature from the API gateway. Important is to know how we address or identify our microservices for each request. Whenever a request enters, you can see, as an example, left, that it's a domain followed with a slash and the microservice name. So we had basically to find a solution how we can forward the request from the API to the backend systems within AWS. Here, one idea would be to go with the VPC link, but the VPC link has today only supports currently only network load balancer, as it is a pretty new feature. And as you might know, network load balancer works on a pretty low level of the ISO-OSI model. So this solution would mean that for each API, we would create one VPC link followed with a network load balancer and then the instance of our application. That was our first idea. Unfortunately, we ran into soft limits. Therefore, we had to rethink and to find another solution. Here we came up that we just could use a reverse proxy, basically an Nginx that we are deploying to Elastic Beanstalk. And within the Elastic Beanstalk, we are addressing all our microservices based on the path from the request URL. Now the point is how you can transfer all the requests to your application load balancer, as the URL of an application load balancer could change. Here we have introduced a private domain zone where we are addressing all our microservices based on microservice name.thestage, for example, test, a private zone. And so you can have a key value pair where you have the name of the microservice and the located and the associated load balancer for it. As a good part of this, we can also reuse the private zone for service discovery purposes. So whenever we have the need for microservice-to-microservice communication, we can just reuse these entries to address or to locate the microservices. So next part is where we deploy our microservices. Where I said before that we are deploying all our microservices on Elastic Beanstalk. Elastic Beanstalk is for us device abstraction to focus on our core capabilities, so mainly providing new features to our platform that our customers can use, without taking care of the underlying infrastructure or all other aspects like platform software updates or retrieving the log files from Docker container. Beanstalk provides several options to deploy your software. You can use an immutable update or a rolling update to deploy your software. Based on the architecture that you see now, we have another option also for exchanging in the whole tech stack. Let's have a look at this. Whenever we would like to go from Elastic Beanstalk to ECS, you could just add an entry within the Route 53 entry. You set the weighted routing value, for example, here 99% and 1%. So all the traffic within the 99% will be flown as before to the Elastic Beanstalk, and 1% will go to ECS. By doing so, you can just have a look at your monitoring, and whenever you see that everything is working fine, you can adjust the value of the weighted routing, and at the end you will come up that you can shut down your Elastic Beanstalk and just working forward with the ECS. So that's a great opportunity and flexibility that the architecture that we have now offers us for changing a whole tech stack whenever we have the need to. We have now talked about the architecture. One additional point is that we need to retrieve all the data from the landscape from BMW. How we are doing this? We are using here CloudWatch event that we can import data in a continuous manner. So CloudWatch event triggers the tasks. In our case, it's Lambda function, and the Lambda function creates based on the data that we want to import, up to 100 jobs to import the data within the AWS Batch. AWS Batch we are using as a queue. So basically, AWS Batch has the job to process the queue and to start containers on ECS to do the import jobs. While doing so, the import jobs retrieves all the data from the backend systems from BMW and inserts into the RDS, so our Postgres DB of each microservices. For us, it is important that the import jobs are really restricted located to each microservice. So each microservice has its own import jobs to retrieve all the data in order to generate new data. For cost efficiency purposes, we are using on ECS only spot instances, so as they are cheaper as the on-demand ECS, EC2 instances. Nevertheless, we have also to speak about our build pipeline. Our build pipeline consists of the following artifacts. We have a Git repository that is still on our on-premise network. We have there the artifacts like the CloudFormation for infrastructure purposes. We have the API in RAML and our business software, so the Java code. The Jenkins has several jobs. For infrastructure purposes, it's only a copy job. It copies the artifact from the Git repository into the S3. For the API, it's a transformation step to transform the API from RAML into Swagger and then copying to S3. And in the last part, for the software, it's building the Java application, running our tests, and if everything is fine, we just copy the build artifact to S3. Whenever one of the artifacts is now entering S3 or gets saved to S3, an automatic trigger triggers the code pipeline. So depending on the artifact that you are deploying to S3, it starts, for example, the infrastructure deployment, the API deployment, or Docker deployment. For us, for production purposes, we have still a manual process on code pipeline. So we have there's someone of us has to check the change set if everything is correct and should be deployed, and whenever if everything is fine, you can just click and deploy it to production. So after we have talked of our architecture and before our go live, we also introduced game days to our organization. The goal of the game day is to train our operation team so that they are well prepared for any potential production problems that could occur. So during the day, they need to solve fictitious production scenarios as fast as possible on our real architecture. We are using gamification as scoring and leaderboards so that they get an incentive to be the fastest team that has solved the problem. Our Chaos Manco team brings some fun in the day. They are creating the problems that could occur, and the team has to solve them as fast as possible. So each team gets a point whenever our services are available, and it delivered as a response. And also we also give additional points whenever the operation team comes up with improvements for our DevOps cycle. It was for us the first time that we are organized such a game day within our organization and for our operation team. And we are keen if they like it or not. And the feedback from the operation team after the day was really good. They liked it because they really could learn the architecture on an hands-on. They can learn the architecture on hands-on experience instead of just having the theoretical basis transferred knowledge how the architecture looks like and so on. So for us, we definitely decided to do such a game day on a frequent schedule, so that the operation team is always prepared on the real architecture, on the updates that we are doing on our architecture. Let me just conclude our talk with some key facts and learnings. Our key facts are that we wrote about 9,000 lines of Lambda code. During the time now we have about 1,800 deployments, and we drank a lot of coffee during the time of the transition. We wrote 3,000 lines of CloudFormation, and currently we have 98 microservices running in AWS. On the learning sides, don't try to make it too perfect from beginning. It's absolutely okay when you when you have an iteration, how you optimize your architecture. It's not necessary that you come up with the perfect architecture just after the transition. We all, I guess, love to discuss technical solutions, but at some point, it's better to try out things within a short feedback loop instead of endless debatings about potential solutions. Continuous learning is, in the context of AWS, also really important. For us, it was a good start to have initial trainings and certifications, but nevertheless, the speed that AWS provides currently is really fast. So it's necessary that you subscribe to any blogs or newsletters to keep up with the speed that AWS provides. Also, whenever you think about doing such a transition or transformation on your own, consider maybe AWS professional services. For us, it was the perfect opportunity to have someone on our side to discuss the solutions and to accelerate from the beginning so that we could just start with the transition instead of starting on point zero. That's it from my part. Thank you for your attention. And whenever you have questions, we are available after the talk and are more than happy to speak with you about it. Thanks.